Hello. So we were speaking about the classification of embedded systems. uh, Embedded systems can be classified based on four criteria. That is, first criteria is based on generation. Second criteria is based on complexity and performance. Third criteria is based on deterministic behavior, and the fourth criteria is based on triggering. So, based on generations, embedded systems can be again classified into four classes. That is, first generation, second generation, third and fourth generation, and that depends on the capacity of the microprocessor that has been used. First generation embedded systems, they mostly used 8-bit microprocessors or 4-bit microcontrollers. The second generation usually used an advanced version, that is 16-bit microprocessors or 6-bit microcontrollers or 8-bit microcontrollers. Then the third generation, it was built around 32-bit processors and 16-bit microcontrollers. And the fourth generation, and this results in the advent of system on chip, the entire system built on a single chip and it uses reconfigurable processors, multi-core processors, and this brings miniaturization into the embedded market. Like examples of such devices include the smartphone devices, mobile internet devices, etc. And second classification is based on complexity and performance. And according to this criteria, embedded systems can be classified into small scale embedded systems, medium scale embedded systems, and large scale embedded systems. Then these were all discussed in the last classes. Then the third classification is based on deterministic behavior, and based on deterministic behavior, embedded systems can be classified into hard real-time systems and soft real-time systems. The hard real-time systems, they strictly adhere to timing constraints. Like if the system should respond within a particular time limit, then and if it fails to respond within this time limit, then the system as a whole fails. So such systems are called hard real-time systems. Missing a deadline may result in permanent loss of data, or it results in irrecoverable damage either to the system or to the user. So such systems, embedded systems, are called hard real-time systems, and their examples are airbag control system. That is, when a vehicle goes into an accident, then the airbag should be released to protect the vehicle, and if it does not work within the particular time limit during the emergency time limit set, then the system is a big failure. Also, anti-lock brake system. The brake should be when there is an emergency, the brake should be applied within almost the time delay should be zero. And so if doesn't happen at that particular time, then the system as a whole will fail, and it may result in loss of uh, uh, the permanent loss of data, or it may result in damage to the users. So then based next is the soft real-time systems classification based on deterministic behavior. The first one was hard real-time systems. The second is soft real-time systems. Now, those real-time systems that do not guarantee to meet the deadline, but they offer the best effort to meet the deadline, they are referred to as soft real-time system. It is not necessary that they should meet the deadline, but a little late, we can, in general, we can say that a late answer is an acceptable answer for real-time systems. But in the case of hard real-time systems, we can say that a late answer is a wrong answer. So that is the difference when we come to real-time and soft real-time systems. For a real-time system, for a hard real-time system, if the system fails to answer within a particular limit, then it is a failure. But in the case of soft real-time system, even if the system fails to answer within the deadline, it is acceptable. And such examples we come across is in ATM systems, that is the automatic teller machines. In ATMs, even if the delay, the machine takes a bit more, it is a delay in giving back the result. We can just wait for a particular some more time and get the work done. So another difference between the hard real-time systems and soft real-time system is that in the hard real-time systems, it does not have a human in the loop. That we call shorten in short we say that HITL. There is no HITL in hard real-time system. If there is a human in the loop, then there is a chance for a delay in the loop. And so in hard real-time systems, uh, usually it excludes human in the loop, whereas in soft real-time system there is a human in the loop accepting input from the human and then responding to his answer. Such systems are called such mostly soft real-time systems. They work with human interaction. So we say that they have a human in the loop, HITL. Then the fourth classification is based on triggering. Based on triggering, embedded systems can be classified into event triggered and time triggered system. Events are any changes that happen in the real world. Once a change happens in the real world, so the system responds to those changes, and such events, such embedded systems are called event-triggered systems. Then another class of embedded systems is the time-triggered systems. Time-triggered systems are those systems that respond to the set time. A predefined time is set, and the system should respond at that particular time. And such systems that respond at that particular time are called time-triggered system. If it fails to respond, then the system as a whole is a failure. So these were the classifications of embedded systems. Hope you're following me. Can anyone say yes or no? Hello? Okay. Can you hear me? Well, okay. So I was going through the classification. Then now the major application areas of embedded systems. We come across embedded systems in most of our day-to-day life, like this has been summarized into around 10 to 11 areas. One university question was this, what are the major application areas of embedded systems? So that's I've included this here. So a few of the application areas include consumer electronics like camera, camcorders, etc. Then household appliances, uh, home automation and security systems like AC, fire alarms, etc. Intruder detection alarms, etc. Then automobile industry. In automobile industry, we apply it for anti-lock braking brake systems. Then and for engine control, automatic navigation systems, etc. And we know that most of the cars today are automated, and they need at least a minimum of 40 microprocessors to control the entire system. Then telecom, computer peripherals like printers, scanners, etc. Then computer networking systems. In healthcare, most of the application of embedded systems come in healthcare, where they use many devices for monitoring the um, behavior of signals generated by the human body, like EEG, ECG machines, etc. Then in measurement and instrumentation, like digital CROs, digital multimeters, etc. Then in banking and retail, we come across ATMs and currency counters, card readers like barcode, smart card reader, fingerprint scanners, etc. So at least we come across one or two embedded systems, or we use one or two embedded systems in our day-to-day life. So these are the major application areas of embedded systems. So what I'm discussing now is the general questions that can be asked from the embedded systems uh, subject. So these are the general questions that could be asked. The next is the purpose of embedded systems. Again, an important question, the purpose of embedded systems. It is designed to serve several purposes, and out of which we can define a few purpose, and any embedded systems come under any of these six. There are six purposes which I have defined here, and we take the case of any embedded system, it will come in either of the six, and six will satisfy either of these six purposes. So the first purpose is data collection, storage, and representation. So embedded systems are capable of collecting data, storing data, and representing data. And one such example of a device that does all the three functions is the digital camera. It is capable of capturing the image, it is capable of storing the image, and it is capable of representing the image to us through the LCD unit. So this camera, it is an embedded system which helps us to, which does all the three functions. Then the second is data communication, like satellite communication systems, networking systems, etc. Then the third purpose is embedded systems can be used for digital or data or signal processing, like for hearing aids, it can amplify the signals for hearing impaired persons. Then the fourth one is monitoring, data monitoring or signal monitoring, like the devices used in healthcare. All embedded products, they come under medical domain. They are used for monitoring functions only. Like we just give an input and we compare the output with the standard output or the normal output, and then this the variation is calculated. Then the fifth one is the control purpose. Another function of embedded system is for controlling, like the air conditioner for controlling the room temperature. Room temperature. Then so the last purpose is the app. It is used for application-specific user interfaces. User interfaces can be generated using embedded systems like the keypad, the graphic LCD monitors, system speakers, vibration alerts. All these are individual devices which can be plugged together to form and a big system. So we use there can be and the embedded systems can be used to connect with other embedded systems and to make a bigger system which does more functionalities than the individual embedded systems. So that was the purpose of embedded system. There were around six purpose for embedded systems. Either they come in any of these embedded systems, they can come in one, or it can come in one or more of these categories. It can satisfy one purpose or more among these. The next is the characteristics of embedded systems. So some of the important characteristics of embedded systems include, first characteristic is that it is application and domain specific. As the definition itself says, embedded systems are designed for a particular application or for a particular domain. So if you have any doubt, you can ask. Okay, in between you can interrupt me and ask. Any doubt? Hello? Can you hear me? I'm just going through what was taken in the last week. I'm just giving you an overall view of what was taken. Okay. Can anyone please respond? Can you hear me? Okay. Okay, Vishnu. So, characteristics of embedded systems. Now, two important 4 marks questions: characteristics of embedded systems, and the next section is quality attributes of embedded systems. So, these are the probable questions which can come for university exam. One is the characteristics of embedded systems. It can be asked as a 4 mark question, and the next is the quality attributes of embedded systems. And among quality attributes, you have operational and non-operational quality attributes. Any of them can be asked for the exam. So first is the characteristics of embedded systems. So some of the important characteristics of embedded system include, the first one is it is application and domain specific. That is, they are designed to perform a specific function, and it cannot be alterable. And once it is designed for a function, it can satisfy only that particular functionality. and it cannot be used for any other purpose. For example, we cannot exchange the control unit of a microwave oven with the control unit of an air conditioner. You cannot remove the control unit of a microwave oven and replace it with that of an air conditioner, because the control unit for microwave oven is specifically designed for that particular device, and for that and that of air conditioner is designed for air conditioner, that for that functionality only. And so you cannot they are all often application and domain specific. Then next is they are reactive and real time. Reactive means if a system changes in output in response to a change in input, then we say that the system is reactive. So what is a reactive system means? If the embedded system produces changes in output in response to a change in input, then we call it as a reactive system. If the embedded system produces change in output based on a change in input, then we call it as a reactive system. Then we say, as the second characteristic says that it is reactive and also it is real time. So what is a real time system? So the next paragraph gives the definition of real time system. So embedded systems are considered as real time systems if they respond to requests from tasks in a known amount of time. Suppose a task is to be done, and if the task is to be completed within a particular time limit, then, and if the system does what it is performs what it has to do, then we say that it is a real time system. So real time system, they should not miss any deadline for the task or operation. So whatever is set to do within a particular time limit is called a deadline. So real time systems, they should not miss any deadline for any task or any operation for which it is designed to. So this is one of the characteristic, that is embedded systems may be reactive and real time. Then the third characteristic is that it operates in harsh environments. That is, it is not often designed to work within a room. It may be there are most of the devices, they have to work in open environment, and where the environment may be dusty, it may be of a high temperature zone, or an area subjected to vibrations and shocks. So most all of these conditions too should be taken care of while designing an embedded systems, and such systems which are placed in these areas, they should be capable of withstanding all the three adverse conditions. So we'll continue in the afternoon. I think I've exceeded time. Okay, thank you. Thank you very much. We'll continue in the afternoon.